Continuing our API Security Fundamentals course with Module 1, we're looking at some top 10 security risks. We are moving to BOPLA, Broken Object Property Level Authorization. So your learning objectives for this module include understanding two of the biggest API threats that have been identified by the OWASP Consortium. We want you to be able to identify these threats on a target application. As we take a look at the top 3 API security risks for 2023, we are going to now focus on number 3. So in the top 3, BOPLA is here, Broken Object Property Level Authorization. Before we get into the specifics of how the BOPLA vulnerability exists, we need to understand exactly what an object is and what are these properties. So in object-oriented programming, there is a concept of objects. Objects are nothing more than abstract representations of real-world entities or real-world things. Now, these objects can contain properties, or you can think of them as members that would hold data, or variables, if you like, that would hold data. You can also represent the behavior inside of the object, and this is done through methods and functions. So for example, if I wanted to represent a car as an object, I would name it car, and I would have properties in it like make, model, and year. I might even have behavior-oriented things like honk horn or press brakes. If you were to translate that into some actual code, we could see it looking something like this. You declare your car. In this case, it's a constant, but it could be a class. And then you see that there are properties that are contained in that class. So you have the make, model, year, color, etc. The behaviors can be captured with functions. And then, of course, there would be the actual invocation of those properties or those behaviors through calling them. So you could have an instance of the car, and then once you have that instance, you can call the property make or year or color, etc. to get the data that's associated with that. And here you see the invocation of the start function. Okay, so now that you understand what an object is and what the properties are, let's take a look at vulnerabilities. So here, once again, we have a lack of authorization checks, but this time it's specific to those properties that are associated with a specific object. There are two subcategories of BOPLA, mass assignment and excessive data exposure. We're going to talk about both in just a moment. And what you need to understand is the impact of the BOPLA vulnerability is it gives an attacker access to unauthorized properties, or think of this as data. So it gives the attacker access to unauthorized data that might be included within that object. So let's take a look at the first subcategory of BOPLA, mass assignment. So due to the nature of exposing properties from an object, there are some unintended consequences where parameters could be added to a request that inadvertently may read, update, or even delete values that are stored in an object. This is considered a mass assignment attack. One of the main culprits for enabling mass assignment is a data model to object generator. So there are code generators that can take your database model and can generate classes from that. Unfortunately, those type of generators create the opportunity for these types of mass assignment attacks. In essence, attackers can craft malicious HTTP requests to include additional fields in the data payload that are not supposed to be modifiable by a user, but because the entire object is exposed, it becomes vulnerable to a mass assignment attack. Let's look at an illustrated example. So here we have our user. They're using a self-registration form that asks for an email and a password. However, the attacker makes a guess that there may be an additional property of isAdmin. Now, maybe it's not isAdmin, maybe it's role or something similar. And what they do is they set that to true, or they set that to role is equal to admin. And the backend server, when it receives the request, because the backend object actually does have this additional field, it will receive it, and then the attacker has added themselves as an administrator into the application. That was not the intent. Every new user was intended to just be a regular user, but with a mass assignment, there's this addition of properties that were not intended as originally coded. The other subcategory of BOPLA is excessive data exposure. So let's look at another picture example. So here you have a user and they go and look at their profile inside of the UI, inside of the web page. They make this request, but the backend presents all properties that are contained in the user object. And this user object, it's bloated because the developers just took a data model and converted it to a class. So the response that comes back exposes sensitive fields like social security numbers, date of birth, password hash, etc. And all of that information goes back in the response, though only a small subset may actually be seen in the UI. But from an API point of view, all of this is exposed. So that is where you get the excessive data exposure. Let's take a look at a case study involving Uber where something like this happened. So Uber exposed an endpoint that allowed leakage of private information. Included in there, unfortunately, were also access tokens. Once an access token is exposed, it can lead to a full account takeover. Let's have a look. So in this call, the user UUID was not being checked against who was currently logged in. So if the UUID of somebody else was exposed somewhere else in the application, you could substitute the one that was assigned in your account with somebody else's. The response that was brought back showed a very bloated object with tons of information. So all of this information was exposed in the response, even an access token, though it is not shown in the screenshot. Let's take a look at some best practices that developers should follow in order to avoid vulnerabilities. First, compartmentalize. Isolate all of your authorization checks in the business layer. Separate these classes from your data model classes. Secondly, enforce property level authorization checks. Instead of using converters, make sure that you're using data transfer objects or DTOs between your business layer and your data model. So now we're going to go into our lab. So the lab that you'll be doing is exploiting a mass assignment vulnerability. These are the instructions you need to follow in order to start the lab. This is the demo for your lab. So now we're going to do the lab on BOPLA, which is exploiting a mass assignment vulnerability. So the first thing we want to do is go ahead and access our lab by clicking the button. In the meantime, we can read through the solution. We're going to use the built-in Burp browser, log into the application with these credentials. We're going to try to buy the lightweight leather jacket and add it to our basket. We're going to click place the order, but we won't have enough store credit in order to buy it. Then we're going to look in our HTTP history and notice that there's both a GET and a POST that call to API checkout. What we'll notice is in the GET, there is excessive data exposure. The entire object is shown that's in the database. And there's an extra parameter that's shown that we can take advantage of called chosen discount. We're going to add that as our mass assignment attack in the post for the checkout. And then we're going to set our percentage to 100% so we can buy the jacket for free. So let's go ahead and see how we can do this. So the first thing we want to do is go to our instance and Control C to copy the URL. Let's open burp. Let's go to the proxy tab, turn off the intercept button, and click the open browser button. Once there, we're going to Control V to copy our instance into the browser's dialog box. Now we should have the traffic on the sitemap, and we should have traffic in our proxy HTTP history table. The instructions told us the first thing we want to do is log into the site. So we will do that with the provided credentials. Once we log in, we want to go back to home, look at this leather jacket, notice the price. We're going to add that to our cart, and then we're going to try to place this order. Now realize we don't have any store credit, so we should be denied this order. And we are. So let's take a look at that traffic inside of burp. So here we have the two checkouts that were mentioned in the solution. I'm going to highlight those just so we can see them more easily. What you'll notice in the initial get is in the response, it shows us the entire object or all of the properties that are in the object that's holding a purchase order. And the one that we're interested in is this chosen discount. Because if we look at our post, all that was provided in the post was just the particular product that we chose to buy. So what I'm going to do is I'm going to right click and send this post to repeater. Let's go over to repeater. Let's just baseline this as it is, so we know that we received the insufficient funds message. Now, what we want to do is we want to take advantage back in the proxy of being able to see all of the properties of this object. So we're going to copy out this chosen discount section all the way up to the comma. You can right click and copy that. Then go back to the repeater and we're going to paste it in to our request. Now, one of the things I've mentioned is when you're in repeater and you want to make a small change, you may want to go ahead and test that change and see if you get any different behavior. So we've not put any percentage in yet to buy the jacket. Let's just see if we still get the insufficient funds. And we do. So it's perfectly fine with us adding this in the request. All we have to do then is just add 100% discount, and we should be able to get our jacket for free. So we do that, and we do indeed confirm the order and solve the puzzle. So in summary, we learned about what an object is and its properties. In our previous section, we learned that BOPLA focuses on a lack of authorization on the object itself, whereas BOPLA focuses on the lack of authorization on the properties that are within that object. We also had a look at the Uber case study with the excessive data exposure.